Hello, welcome to the presentation on what is pH. This is section 19.3. Let's take a look at some basics, what pH is. Hydrogen ions from water, that is what we're looking at. The hydrogen ions, remember they contribute to what pH is. Water in its standard state is a liquid. Does not stay at H2O all the time. It dissociates by itself automatically to form the H plus ion and the OH minus ion. And that H plus ion does not typically stay at an H plus ion. It combines with another oxygen to form this H3O plus, and that's called a hydronium ion. The OH is the hydroxide ion. We're familiar with that from our talks on ionic compounds. This is called self-ionization. It does it automatically. And the ion product constant is associated with this. When it dissociates, you get a certain amount of hydrogen ions and a certain amount of hydroxide ions. If you take the concentrations of each of those, multiply them together, you get 1 times 10 to the minus 14th. That is the ion product constant of water. If you have a concentration of H plus that is exactly 7, that is a neutral solution. That's for just for regular plain deionized water, nothing in it. If you have a solution of something and the concentration of the H plus ions is less than 1.0 times 10 to the 7th, then it is a basic solution, also called an alkaline solution. If it's greater than 1.0 times 10 to the minus 7th, it is called an acidic solution. It's an acid. So remember, what the key to remember here is if you're looking at these concentrations, these are to the negative exponents. So a concentration of 1.0 times 10 to the minus 8th, times 10 to the minus 8th is a basic solution because it's less. It's less than this number because we're looking at the negative exponents. So 1.0 times 10 to the minus 8th times 10 to the minus 9th or minus 10th. Those are all less than 1.0 times 10 to the minus 7th. So those are going to be basic solutions. Greater than 1.0 times 10 to the 7th, 1.0 times 10 to the minus 4th is greater. So that is going to be an acidic solution. Let's take a look at some practice problems. We know that the concentration of H plus times the OH minus is equal to 1 times 10 to the minus 14th. So if we're given a problem like this, where we're given the concentration of H plus, we need to figure out what the concentration of OH minus is. We can just use that formula. Concentration of H plus times the concentration of OH minus is equal to 1.0 times 10 to the minus 14th. When we solve this, we are given H plus. So 1.0 times 10 to the minus 13th times the concentration of OH minus is equal to 1.0 times 10 to the minus 14th. We're solving for OH, so we'll just divide both sides by 1.0 times 10 to the minus 13th. And we'll get an answer of 1.0 times 10 to the minus 1. So that's going to be our answer right there, just using this basic formula right here. H plus times OH minus, the concentrations, is equal to 1 times 10 to the minus 14th. Another example here. Same thing going on, but here we're giving OH minus, H plus, OH minus, 1.0 times 10 to the minus 14th. It's always good to write that down, helps you learn it. So we solve concentration of H plus times the concentration of OH minus, which we're given 1.0 times 10 to the minus 7 molar, equals 1.0 times 10 to the minus 14th. We need to solve for H plus. Divide both sides by 1.0 times 10 to the minus 7th. And we will get 1.0 times 10 to the minus 7th for our answer. It's going to be molar. You can do the same thing. You can work this problem out yourself. Do it on your calculators. Check it out. See what you get. Do the calculations. See what you can get for the concentration of H plus. So you try that one. And the answer will be 1.0 times 10 to the minus 11th molar for that one. Try it yourself. See if you get that answer. Let's move on to the next topic here, pH. We've all heard of pH before. pH is related to the concentration of the H plus ion. The higher the concentration of the H plus ion, the more acidic it is. And this pH tells us on a scale of 1 to 14, or 0 to 14, how much we have, how much H plus we have in there. What it is the pH is equal to the negative log of the H plus ion. So on your calculators, you'll need to find the log key. On your graphing calculators, it is going to be right next to the 7 button. Right next to the 7 button is what is where that log key is going to be. On your other calculators, a Texas Instrument TI-30, for example, that is going to be directly below the 2nd key. So it's going to be in the upper left-hand corner, way in the upper left-hand corner. It's going to be the log button. So you're going to see that log button. It's going to have a log on it. So that's going to be the button. And also right above it, the 2nd key is going to be 10 to the x. That's the inverse log. We're going to need that in a short time here. So keep that in mind also. So the pH is equal to the negative log of the H plus ion. We also have a concept called the pOH. Just the opposite. See how basic something is? It's going to be the negative log of the concentration of H plus, excuse me, OH minus ions. So we have those two formulas. We also know another formula, very, very handy. Be definitely using this one in a number of calculations. pH plus pOH is equal to 14. Very good to know that when we go from concentrations to pHs and pOHs. You have that pH island in front of you. Take a look at that. There's different ways you can go from one thing to another. It's going to be easiest if we go through this pH plus pOH is equal to 14. Very easy calculation to do. We're going to get to that in a little bit here and how to use that. Just keep that in mind. So here we have a couple of formulas. pH is equal to the negative log of the concentration. Remember that concentration is going to be in scientific notation. One thing I didn't mention on the previous slide, but if you have a concentration, we'll just make this up, 1.0 times 10 to the minus 7th on your calculators. 1.0, use that EE button, -7. Do that negative key on the bottom of the calculator. Have to use that EE button. Typically, it's going to be located the 2nd function associated with the button right above the 7. I think that's the same on both calculators. So definitely use that. Otherwise, you might run into problems with getting the wrong answer. Let's take a look at some practice problems. We're trying to find the pH when we have these concentrations. So for this first one, we have the concentration of H plus is equal to 3.6 times 10 to the minus 9th molar. We know that the pH will be equal to the negative log of the concentration of H plus. Just saw that formula in the previous slide. We're given the concentration of H plus. So all we need to do is plug into our calculators, and this is the way you're going to have to do it. Do the negative sign, not the minus sign, just the negative sign. Log, type in that log key. It'll automatically come up with a parentheses there. You get 3.6. Do that EE button. Just a single E will display. Then again, -9. You can close out the parentheses if you want. And you will come up with your answer at 8.44. And that's the answer right there. One thing about pHs. Some of you will like this. pH has no units. It's one of the very few concepts, few numbers in chemistry that do not have a unit associated with them. So the answer is just the pH is 8.44. That's it. No units at all. So that's how we do the pH, negative log of the concentration. If we're given OH minus and we're trying to solve the pH, it's going to be a two-step process. If you take a quick look on your pH island, we're looking to figure out for this one, what is the pH? So we're trying to figure out what the pH is. We are given OH minus. So we need to get from concentration of OH minus up to the pH. So we can't go there directly. There's no lines leading there directly. We can't go directly in that direction because there's nothing leading there. We need to go around. We need to go somewhere first and then someplace second. Like I mentioned before, this calculation right up on top there, pH plus POH is equal to 14. If you can go through that, do it. It's an easy calculation to do. So what we should do is go up to POH and then over to pH. That's the easiest thing to do. Let's just go ahead and do that for this problem. If we're given the concentration of OH is equal to 1.0 times 10 to the minus 6th, we know that the POH is going to be the negative log of that concentration, 1.0 times 10 to the minus 6th. We get that answer, that's going to give us 6. And again, POH does not need a unit. Now we need to solve our second equation, pH plus POH is equal to 14. We know our POH, so pH plus 6 is equal to 14. So that'll give us pH is equal to 8. It's a two-step process. Again, knowing how to use this island, knowing how to use pH island makes it easy. And again, anytime you can go through this, if you have a two-step process, either going from H plus to POH, you want to go up and over. If you're going from OH, concentration of OH to pH, go up and over. Every other case is just going to be the matter of going from one thing to another, where you can do it all in one motion. So if you just do it in one step, that's what you're going to want to do. If you're given concentration of H plus and you need to get to pH, follow the arrow. You can see there's arrows going up and there's arrows going down. So just follow the correct arrow. Going from H plus to pH, you'll use this one on the outside there. All right, let's get back to our presentation here. There's another one that you can do. You should try this one yourselves. You should work the problem. And when you do that, just to test yourself, you'll get a pH of 10.81. So try that one yourselves. See if you can get it. See if you can get that 10.81. So here's another equation here. What are the concentrations of H plus and OH minus when we are given the pH? So here's our formula for that. The concentration of OH plus is going to be this 10 to the x. This is the inverse log, the second log. So you get that this 10 to the x is right above that log key. So you'll need to press the second log. We'll give you the inverse log. Just like any other thing on your calculator, there's the function and the inverse function associated with it. Just like in trigonometry with the sines and the cosines and the tangents and cotangents and so forth. So here we have it, this 10 to the x of the negative pH. So here's an example. If our pH is 2.37, what is the concentration of H plus? We know that the concentration of H plus, here's our formula, is equal to 10 to the power of, so that's what we need to do, 10 to the x of negative 2.37. Press our equal sign, and we'll get our answer. Our answer for this one is 4.27 times 10 to the minus 3 molar. So there's our answer right there. Inverse log of the negative pH. If we're trying to figure out pOH, or if we're trying to figure out the concentration of OH minus, again, look at your pH island. You want to go from one corner to the other. You always want to pass through the formula that reads pH plus pOH is equal to 14. We know our pH, 2.37 plus pOH is equal to 14. We know that pOH will be equal to 14 minus 2.3, or it will be 11.63. And now we can figure out the concentration of OH minus, because it's going to be the inverse log, 10 to the x, of the negative pOH, 11.63. So once you plug that into your calculators, you'll get 2.3 times 10 to the minus 12th molar. So there's going to be your answer. Solving it, again, using your pH island, going from one thing to another, utilizing those new functions that we looked at, the log, the inverse log, and so forth. Second one for you guys to try. pH is equal to 11.05. You need to calculate the concentration of H plus and OH minus. These square brackets, I think I forgot to mention this, represents concentration of. That's going to be the concentration of. So for the concentration of H plus, it will be 8.9 times 10 to the minus 12th molar. 8.9 times 10 to the minus 12th molar. pOH will be equal to 1.1 times 10 to the third molar. So try this one yourselves. See if you can get those numbers. Should be able to get those numbers. Remember, when you figure out this pOH, it has to be the two-step process. Easiest thing to do is figure out, the concentration of OH, is to figure out what pOH is first. Figure out what that is first. It's a lot easier to do that than go the other way around. Measuring pH, we can use indicators. I'll have a demo of this when we do our titration labs. Show you what indicators are, how they work. There's also pH meters. pH meters um, tell you accurately what the pH is, down to 2 decimal places. They're used quite a bit in industry to determine what the pH is. A lot of times you'll need a slightly acidic or a slightly basic solution, or you can't have a slightly acidic or you can't have a slightly basic solution. So pH meters are used quite often to measure the pH, and the pH is adjusted from there in one way or another. That concludes our presentation. Hopefully you enjoyed it.